For today's lesson, I want to go through kind of the next step in our molar conversion. So we talked about Avogadro's number and what that means. And so just as a quick refresher, in Avogadro's number is this 6.02 times 10 to the 23rd particles. And whenever we have that many particles, that means we have 1 mole of something. The worksheet you kind of worked on last week, you did conversions between moles and grams. And you got the molar mass from the periodic table. And if you took that that atomic mass units from the periodic table, made that in grams, that is exactly 1 mole of a substance, meaning that you had this many particles. So we're going to kind of go to that next step of conversion for today's worksheet. For today's lesson, you are going to do a couple of conversions. You are either going to go, if you're given moles, then you need to convert to particles. And particles might be numbers of atoms, numbers of molecules, or numbers of formula units. But just remember, if I start with moles, then my conversion factor is going to be Avogadro's number on top over 1 mole if I want to get rid of moles and end up with particles. And again, particles could be molecules or atoms or whatever we're talking about. The other possible conversion factors, sometimes you're given numbers of atoms or numbers of molecules, so you're given particles and you have to convert to moles. So you're going to use this same conversion factor, 1 mole. 1 mole is equal to 6.02 times 10 to the 23rd particles. So if I want to end up with moles, then I use that as a conversion factor and I put moles on top. So for example, if I want to know how many atoms are in 2.5 moles of carbon, I start with 2.5 moles. You can see the path is going to be going from moles to atoms, 2.5 moles. And then I'm going to multiply that by, use the conversion factor, 6.02 times 10 to the 23rd atoms, because that's the type of particles I'm talking about in this particular equation, over 1 mole of carbon. And then I just multiply that out. Make sure, so I'm going to take 2.5 times 6.02 times 10 to the 23rd. I have to put this in parentheses so that my calculator knows that this is just 1 number. So I multiply those 2 numbers, and then I divide by 1 times 1, which is just 1, and calculate that out. Another example, and please write these down so you have some reference, and there's lots of examples in your book too. If I want to know how many moles are in a sample of neon containing 5.6 times 10 to the 18th atoms, now I'm going from atoms to moles. I start with 5.6 times 10 to the 18th atoms of neon, and then my conversion factor is going to be moles on top and then atoms on the bottom. And again, make sure that you're putting those parentheses around these scientific notation numbers. So let's say, just to kind of introduce a 2-step equation here, if I had 75 grams of copper and I wanted to know how many moles that was, I would have to look up the molar mass from the periodic table and do this calculation, which you guys did a lot of last week on your last worksheet. And then if I want to know how many atoms that is, I actually can do that. But first I had to convert it into moles. So once I know how many moles there are, then I can use that conversion factor with Avogadro's number to get rid of moles and convert this all the way to atoms. So in knowing that molar mass and understanding how Avogadro's number works, if I have the mass of a pure substance and I know what atoms are in that substance, I can, if I know the weight in grams, I can actually calculate how many atoms are in that. I did this as two separate equations. Of course, we can do that as one equation, which is how we should do in chemistry going forward. So if I have 75 grams of copper, I can calculate this all the way across, and I didn't put the answer on here, but I can calculate this all the way across. I can first use the conversion factor that gets rid of grams and gets me to moles, and then I can use the conversion factor that gets rid of, so I put moles, get rid of moles on the bottom and calculate it all the way to atoms. And again, make sure that you're putting parentheses around these. So we can do this all as one step.